In this section, we talk about instrumental variable regression with one endogenous regressor and one instrument. So let's go back to our simple linear regression model, which you are quite familiar with. You have the dependent variable and you have one independent variable, and you have the intercept and the slope, and of course the population error term. So in this case, the x variable is endogenous. And what does that mean? It means that its value is affected by other components within the model. In this case, the correlation between the x variable and the error term is non-negative, which means that if you nudge the error term a bit because of an external shock, then you would at the same time nudge the x value a bit. So if the x and the u has a positive correlation, then a positive shock to the error term would probably cause a positive movement in the x variable. So, and this is why we call the x a endogenous variable. And in contrast, we have the exogenous variables, and exogenous variables, they are not affected by the state of the system or the other variables in the system. So if you, for example, induce a shock in the error term, an exogenous variable would not be affected by that. Remember that to do the instrumental variable regression, we need to split the x variable into an x hat, which is not correlated with the error term, and a component v, which is containing all the information which is correlated with the error term. And to do this split, we need a third variable, which we call the z, and this is the instrumental variable. And in order for this instrumental variable to be useful for us, then the correlation between the instrumental variable and the x should not be 0. So there should be a correlation between our x and the instrumental variable, because we are going to use the instrumental variable to say something about or predict the x variable. And the instrumental variable, it has to be exogenous, which means that the correlation between the instrumental variable and the population error term should be 0. Because if the correlation between a variable and the error term is positive or negative, which is non-zero, then that variable is endogenous. If these two conditions hold about the instrumental variable, then we can use that instrumental variable to capture the information in x, which is exogenous, and leave the endogenous part behind. And this will enable us to estimate the true beta, the true effect of x on y. And this is actually quite hard to do, or the hard part is actually to find the proper z variable, the proper instrumental variable. because the instrumental variable should be correlated with the x, but at the same time, it should not be correlated with the error term, and it should not be correlated with the y variable. So in this case, you have to find a variable which is correlated with x and not with the y or the u.